This video contains the solutions to take-home problems number 18. For this one, they give us a piecewise defined function, and we just want to evaluate this function at various different numbers. So the key that you have to follow here is that whatever number you're given inside the parentheses for the f, you need to figure out which one of these cases fits that number. So for the first one, we've got f of 2, and so which one of these three cases fits the number 2? Is 2 less than negative 2? No. Is 2 between negative 2 and 3? Yes. So that means that we use this function to evaluate that. So f of 2 is 2 squared, which is 4. For f of 5, 5 fits into this third case because 5 is greater than 3. So my y value is 10 minus 5, which is 5. And then finally, for f equals negative 2, we've got to be a little bit careful here because we see negative 2 in a couple different places. But the first case talks about x being less than negative 2, and negative 2 is not less than itself. And the second case here talks about x being greater than or equal to negative 2. And so that means that this fits into this second case. So f of negative 2 is negative 2 squared, which is 4. All right, same piecewise defined function here, and now we're asked to solve the equation f of x equals 9. Now, as far as we know, we could get the y value of 9 from any of these three cases. So what we're going to do is we're going to set each of the equations equal to 9 and solve, and then see if the solution or solutions that we get fit with the values of x that give us those functions. So 2x minus 1 equals 9 gives us 2x equals 10, and x equals 5. So does that solution fit with the inequality for that case? Is 5 less than negative 2? No. So that means that we throw that solution away. For x squared equals 9, we get two solutions, x equals plus or minus 3. And then now we look at the inequality for that case. Negative 3 doesn't fit because negative 3 isn't between negative 2 and positive 3. But positive 3 does fit, again, because we've got a less than or equal to sign. And so that means that x equals negative 3 is not a solution, but x equals 3 is. And then finally, for this last case, we get 10 minus x equals 9, add x to both sides, subtract 9 from both sides, and we get x equals 1. But 1 is not greater than 3, so we have to throw that solution away as well. And so the only solution that we get is that x equals 3. Now finally, for this third problem, we're asked to graph the function. So we want to graph y equals f of x. So what we're going to do is we're going to piece together the graphs of these three functions separately. We know how to graph 2x minus 1, that's a line with slope 2, and y-intercept negative 1. We know how to graph y equals x squared, that's a simple parabola, and then 10 minus x is also going to be a line. So what we're going to do is find the points where these functions change over. And those happen at negative 2, because that's where we change from the first case to the second case. And then also at positive 3, because that's when we change from the second case to the third case. So we're going to plug negative 2 into both the first function and the second function. When we plug negative 2 into the first function, we get 2 times negative 2 minus 1, which is minus 5. And when we plug negative 2 into the into the second function, we get negative 2 squared, which is positive 4. So we're going to plot both of those points. But when we plot, so negative 5 here and 4 here. But when we plot the point negative 2 comma negative 5, we're going to plot it with an open circle because we have a less than sign. This function doesn't actually go through the point negative 2 comma negative 5. It gets really close to it, but it never actually goes through that point. So we're going to plot it with an open dot. But then negative 2 comma positive 4, we plot that with a filled in dot because the function really does go through that point because we have a less than or equal to sign there. Now, what does the function look like to the left of the point negative 2 comma negative 5? Well, it's a line with slope 2, and that means that the function is going to look like this. It's going to be a line with slope positive 2, and so to the left, for x less than negative 2, that's what my graph looks like. Now let's go ahead to the x equals 3. So at x equals 3, again, we're going to plug 3 into both functions. So we get 3 squared, which gives us 9, and then we get 10 minus 3, which gives us 7. We're going to plot 3 comma 9 with a filled in dot because that's where the less than or equal to sign is. So there's 9 and there's 7. So up here, I plot a filled in dot at 3 comma 9, and then an open dot at 3, 7, because the function doesn't actually go through the point 3, 7. So between -2, 4 and the point 3, 9, I have my parabola, just like we normally have for y equals x squared. So it looks like that. And then beyond, to the right of the point -3, 7, I've got a line with slope -1, and that means that the line is going to go down as I go to the right. And so that's what my function looks like. All right, lots of words here, but eventually what we're going to be wanting to do is to create a piecewise defined function that gives the tax paid by an individual person whose annual income is X dollars. So when we read this problem, what we should be picking up is that there are really two cases. An individual making less than $30,000 would do something, and we'll come back and read that more carefully in a second. And then those making $30,000 or more would do something else. And so just that is enough for us to know at least what the two cases are for our piecewise defined function. Because one case is individuals making less than $30,000. The annual income is X, so that would be if X is less than $30,000. And then the other case is for individuals making $30,000 or more. That represents X greater than or equal to 30,000. And so now all we have to do is read the descriptions of what we do in each of those cases and then figure out the formulas. So what do we do if you make less than 30,000? Well, it says we would pay taxes equal to 15% of their income. So 15% of X, that's just 0.15 times X. Now what do we do if we have 30,000 or more? Well, it says we would pay 15% on the first 30,000 of income. So that would be 15% of 30,000, and then 30% of the excess income above 30,000. So 30% of the amount above 30,000. And if we want the amount above 30,000, all we do is we take X minus 30,000. How much more than 30,000 do you have? Well, you subtract 30,000 to figure out how much more than that you have. Now we could simplify this second equation, or this second expression here. We could multiply that out and collect like terms and simplify it, but we can also just leave it the way it is. All right, a similar problem here. We've got a lengthy description of a scenario, and then again we're asked to create a piecewise defined function. So the first thing we're going to figure out is what are the cases? What are the different values of T, right? So T is how many therms we use, therms of natural gas. And so we need to figure out what are the different cases. So if we look at this, what we can see is that we charge a certain amount for the first 150 therms, and then more for each additional therm. And that means that our two cases are going to be whether we have more than 150 or less than 150. So since we're looking at the first 150, we're going to include 150 in that first case. So our first case is going to be if T is less than or equal to 150. And then the second case only comes into play if we have more than 150, right? Because if we don't have any additional therms above 150, then we don't have to worry about that second case. Okay, so what do we do for the first 150 therms? Well, we're charged 12 cents per therm for the first 150. So we've got our monthly rate of $15, and then we've got 12 cents per therm, so 12 cents times the number of therms, which is T. We also have the supply charge of 68 cents per therm, and that's charged no matter how many therms we use. So that's another additional 0.68 times T. So it's 12 cents per therm times the number of therms, plus 68 cents per therm times the number of therms. Now we could multiply that out and simplify it, but that's the basic formula that we would have for the situation when T is less than or equal to 150. Now when T is greater than 150, we still have to pay the $15 monthly charge. We still have to pay 12 cents per therm for the first 150 therms, so that would be 12 cents times 150. But now we're going to pay 5 cents for each additional therm. So that's going to be 5 cents times the number of therms in excess of 150. That's T minus 150. And then additionally, we still have to pay the 68 cents per therm. And so we also have 0.68 times the total number of therms T. And again, we could take all of that stuff and multiply it out and simplify it algebraically, but that would also be the formula that we have for T greater than 150.